So our goal is to be able to identify an n by n identity matrix. I already told you that one earlier in the hour. If you had to make an identity matrix that had 4 spots in it, would you please write what the numbers would be for the identity matrix that looks like that? 2 by 2 identity matrix. I know you know, but just write it down. And then just write identity next to it. See, I'm going to teach you like 4 things today. Identity matrix is super easy. It's the first one. Then I'm going to teach you how to do an inverse matrix. And to do that, I'm going to have to teach you how to do a determinant. And I'm going to have to show you how to do it all on a calculator. All right. This was the identity matrix. 1, 0, 0, 1. If you multiply any matrix by, that's like a 2 by 2 matrix, by a 2 by 2 matrix that does that, you will get the exact same matrix back. So if I had 5, 6, 7, 8, it would give me the answer of 5, 6, 7, 8. That's an identity matrix. All right, what's the next thing we got to learn? The determinant of a 2 by 2 matrix without a calculator. All right, why won't you just do it on a calculator? Well, it's kind of actually easier to do, and it's also good for you to know what the calculator is doing. All right, and then we're going to find the inverse of a 2 by 2 matrix, which is different than a determinant, which is different than an identity matrix, without a calculator. And then we're going to do one with a calculator. And then I'm going to tell you when you can't even get an inverse. All right. By the end of the hour, we're going to be learning about solving an equation using the inverse. This is an intense one. So, do you get that that will not give you this back again? You got that now? All right. If I change these to zeros, then it would. Okay? That's called the identity. All right, next slide. Here's a bunch of identity matrices. Get those? Got that? What happens if you times by the identity? Well, what's the answer to this one? 5, negative 4, 1, 8. Yep, just you get this back again. That's what that does. All right. On to this page. An inverse operation is the operation that undoes another thing, like add and subtract are inverses, multiply and divide. Square and square root. Those are inverses because they like undo each other. Matrices have inverses too. If you put a little -1 power, that's the inverse. All right, let's talk about with numbers. If I had 5 and I wanted its inverse, I would do 5 to the -1. And then, can you do that in your head? Do you remember what that does? What does it do? What does 5 to the -1 equal to? 1 over 5. So if I put 5 to the -1, I get 1/5. Those two are inverses of each other. So when you put something to the -1 power, you're getting its inverse. And what do inverses do? When you multiply them, they equal 1. That's what inverses do. So we're trying to find inverses now for matrices. All right. So the inverse of a matrix, here's a matrix, and here's the inverse being done to the matrix. We'll do 1 over AD minus BC. Man, this seems so complicated. AD is those two diagonal ones, minus B times C, which is those two. That right there, that's called the determinant. DET. Go ahead, write that down. It increases the chances you're going to remember that that's the determinant. And then, where the heck did these all come from? Let's take them one at a time. A and D. Did you see those anywhere in the earlier problem? Yeah. It looks to me like you just take A and D and you flip-flop them. You switch their places. These two get that flip-flopped. And then B stays there but becomes negative, and C stays here, was here before, right? And it just becomes negative. So those two become negativized, You make them the opposite of what they are. And these two switch places. And then you times by 1 over this thing. Whew, intense. So imagine for a moment that we actually put in numbers here. We'll just write them right next to it. Let's say this is a 5, and this is a 1. Let's say this is a 4, and this is a 2. You do 1 over 5 times 2. See, this is 5 and this is 2. Minus 4 times 1. Technically 1 times 4, but it doesn't really matter. So 5 times 2 is 10, minus 1 times 4 is 4, so 10 minus 4 is 6. So this is 1 over 6 times, and then the D and the A reverse. So the 5 was at the top corner, and now it's at the bottom corner, and then the 2 was in the bottom corner, now it's the top corner. And now these two were 1 and 4, and so they stay the same place, but they become opposite. Could you multiply all of those by 1/6? That wouldn't be that bad, would it? Final answer would be multiply this by 1/6, then it becomes 2/6, 4/6, 1/6, and 5/6. Now I don't have to multiply by 1/6 anymore. And yes, it can be reduced, but there is my inverse. Now, if I take my original, which was 5142, and I multiply it by that nasty looking thing, it'll equal 1. That times that crazy set of fractions would equal 1. Now, do I expect you to be able to do this in your head? No. Slowly and carefully on a piece of paper, yeah, you're going to have to know how to do that. So let's try it one more time without the notes on it. Ready? Live without a net. 4, 10, 2, 5. There is our matrix. Now, for some reason, we want to be able to multiply by something and have it equal 1. And that means we need its inverse. To do that, if we could just use the calculator, which we will in a minute, we could just go 4, 10, 2, 5, and put it to the -1. Because you remember how that's what the inverse is? And the calculator could do that for you. It could do all of that crap that we're going to have to do for you by just typing this into the calculator and putting it to the -1. But if you have to do it by hand, here's what you would do. You would take your original one, and you'd multiply by 1 over that times that. Let's make sure which ones are being multiplied. AD. Nope, nope. That one's not first. Even I messed it up. That one's first. 4 times 5, and it doesn't matter if it's 5 times 4 or 4 times 5, it's times. Minus the other 2 times. 2 times 10. And all of that is times by another matrix, which is, do you remember the deal we do with these again? Do you remember that the 4 and the 5 flip-flop? And the other two stay the same except what? But they're negative. This can be simplified a little bit. So 1 over 20 minus 10 is 1 over 10, isn't it? No, it's 20 over 10. 1 over 0. There you go. So it's undefined. If the determinant, which is this part, If that part is 0, then you get 1 divided by 0 means does not exist, right? If this part, which is called the determinant, the DET, if that determinant is equal to 0, then you know this thing won't have an inverse. All right, so a little review now. Don't write this, listen. Can I multiply by something that'll keep it the same? What's that called? Identity. What should I multiply by to keep it the same? 1, 0, 1. Oh, 0, 1. Right? Okay, what was that called again now? Identity. Could I multiply by something that'll make it equal 1? If I multiply by the inverse, it'll make it equal 1. How do I get this to be an inverse? I can either go 2, 1, 3, 4, and put it to the -1 on a calculator, or I can do that nasty process I just did. Take a second and see if you can do it. Do you remember it? It was 1 over a fraction. Four times 2 is 8, minus 1 times 3 is 3. Did anybody start with 1/5? Okay, good. And then I got to flip-flop the 2 and the 4. 4, 2. Make this negative, make this negative. That's not that bad. You could do that. And then really when you multiply everything by 1/5, this just becomes 4/5. -1/5, -3/5, and 2/5. And then it's not there anymore. I just multiplied it into everything. Cool. We just found out what? There's a lot of I words. What was this? This was an inverse. And in that inverse process, we used the determinant. Can anybody name what the determinant was here?
5.
It's 5 because it's the 8 minus 3. It's that part right there. Where'd that come from again? That came from this times this minus that times that. Except it was these numbers. Okay, there. You've learned everything by hand. And I'm not saying you're awesome at it, but I think you could do it if you had enough practice. But now we got to get to the calculator part. All right, so now, on your calculator, of course, this is about matrices, right? So you're going to find the button called matrix. This is an important moment to have a partner. I know for some of you, you're like, I don't want a partner. Well, you're going to have a partner anyways. This is important because there's only one of me. And there's going to be like 5 people who get stuck. I need you to be able to talk to the person next to you as your partner in order to get that help. These 2 rows slide next to each other, 6 inches apart. These 2 rows, 6 inches apart. Bring your iPad with you. Actually, I'm going to get some slide over there. Please try to include her in your group of 3. All right. Now everybody's got somebody next to them that has a calculator. Either it's on their iPad or it's on their calculator. All right. And now you got to help each other if you get lost. The first thing I want you to do is find the matrix button. Do you get it's above another button? Find this button if you haven't already found matrix, and above it you will find the word matrix. And to get to it then, obviously you can't just hit that button. You have to hit second and then that button. And then what comes up is a whole bunch of A, B, C, D, E, and they're all in little matrix brackets. All right, And then that's called names. We probably won't ever have more than just the A and the B matrix. We're not going to be doing like things that have 12 matrices. Okay, you might have two, the A matrix and the B matrix. Probably won't even use these. But you got to tell what the A matrix is. It probably on yours defaults to a 3x1, does it? Or does somebody have like a 2x2? Or what is your default to? Mine defaults and says 3x1 next to it. What does yours say next to the A matrix? Oh, okay, so you don't have anything in there. That must mean that if you've never used the matrix, this will be blank. How many of you it's just blank right next to it? That's almost everybody. So you haven't done a matrix before in your life. All right, good. Now you're about to. All right, so if we want the A matrix to be something, like I'm going to tell you what we're going to make A. It's going to be 1, 2, 3, 4. Would you agree that that is a 2x2 matrix? All right, so then I want you to arrow over past math to edit. Arrow over to edit and hit enter on the A matrix. You're editing the A matrix, and this is what it says. Matrix, bracket A. And then you want to tell it that we're using this matrix right here, that you want a 2x2 matrix. So tell it 2 by 2. You'll use arrows to get around. And then actually type in 1, 2, 3, and 4. These little elements of the matrix, put them in. It's actually kind of hard to get this right. So be there for your partner if they're struggle busing. Do you have matrix A in as 1, 2, 3, 4? All right, everybody double check that their partner is good. Everybody good? All right, then hit quit. It feels wrong, but hit second quit. You need to get out, and it feels like you just lost everything. No, it's still there. It's like a Google Doc. It's saved there already. So now if I want to do the A matrix to the -1 power, what I really want is A to the -1. That'll give me the inverse of it. And it'll do all of that really hard work, just the calculator will do it. I can't tell if you got one of those removed or you... Yeah. Okay, got it. Okay. So then, my question is, how are we going to get this A to come up so that we can do the -1 power to it? Play with your calculator. Try to figure out how. Take a wild guess where that might be. Talk to your partner, see if you guys can figure it out. Now, I hesitate to just say, do you get it? The way I'll tell you can get it is you'll know what the 4 numbers are. How many of you have those 4 numbers up on your calculator? Awesome. Everybody's saying they're getting it. If you didn't get it, what you had to do is type the matrix button, hit enter on the A, and the A pops up on your screen like this. And then you just put it to the power of -1, which you could do with caret, -1, or even better, there's a key for that. And the key has this on the key. It says x to the -1 key. And that would do it. And then you get the actual inverse, which is -2, -1/2, and a 1 here, and a 1.5 there. Now, this probably is a 0.5 for you. Any questions on that? Now, what would that thing even do? Well, it would take our 1, 2, 3, 4 matrix, and if we times it by this, what will it do? That's the whole point of an inverse. It makes it equal 1. Yeah. This times this would equal 1. All right. Now, let's see what's faster. If I just asked you for the determinant of this, that's that little deal. We use this and this. Do you get how it's pretty fast? You just go 1 times 4 is 4, minus 2 times 3 is 6, and it comes out to -2. Raise your hand if you knew it was going to be -2. Awesome. So, do you need to know how to do that in a calculator? I don't think so. Except, what if it was a 3 by 3? That'd be more complicated, wouldn't it? All right, so maybe we should know how to do a determinant. Let's try to figure out how to do the determinant of the A matrix. What could we do to the A matrix that would give us the determinant of it? I want you to go into the matrix menu. Try to find it. Raise your hand if you already found it. Ah, that's like half of you. If you haven't already figured this out, it's under the math menu. Go into matrix and then math. When you're on the matrix menu, go to math. And then do you see a thing called DET? All right, we already know the answer is -2, but would you please do DET of A and make sure you know that that actually works. Due to the determinant of A. Now, there's usually a few people that really struggle with this, and I get it. If you have to, just completely wipe it out and try over again. It's under the matrix menu. Math menu. And what it should say is DET of bracket A, which is matrix A, is -2. That should be on your calculator right now. If it's not, that means you missed a memo and you missed this, and you need to get it from your friend next to you. Please do that, and I'm about to walk past, and I want to see everybody's that you have done this. It's either on your calculator right now or it's not. If it's not, ask the kid next to you for help.
My coach isn't having me today, but I think I'm gonna try to do it. We'll see. I know some reasons I don't. And so only you guys have bring forward
All right, I feel like, I don't want to check the whole room, but I feel like we got almost everybody. Okay, any questions? Then zip through the rest of the slides real quick. So go to this page. The determinant, ooh, that's the DET thing. We just learned how to do that. Remember, it's that times that minus that times that. But that part, the determinant, is just that times that minus that times that. The calculator can do it for you. Especially handy if it's 3 by 3 matrix. Okay, go to this one. Inverse. Do you know how to do that with a calculator now? You get the matrix to come up, and you put it to the -1 power, and it's going to do all of that for you, which is really nice. It's finding the determinant, it's doing 1 over the determinant, and then it's taking A and the B, or A and the D, and switching them around, see? And then it's making the B opposite and the C opposite of what they were. Okay, that's what it's doing when you just do that. But that's so much easier on a calculator. All right. So, how or when we're going to ever use the inverse thing? If you were solving this equation, you would just subtract 6 from both sides. Because you know the inverse operation. Inverse of add 6 is -6. Well, this is an inverse just like that, when you're solving this. Everybody please zoom in on this. This is at the bottom of page 7. If you were going to solve this x and y need to get alone. Can't you just divide both sides by this? No, there's no such thing as divide in inverse world. You'd have to multiply by the inverse. This is going to be matrix A. This is going to be matrix B. How are we going to get matrix A off of there? Multiplying it by the inverse. Now, this is important. Pay attention to this. Do you remember that do you remember that when you multiply something, that 7 times 8 and 8 times 7 aren't the same when you're in inverse world? You can't just reverse them, right? The order matters. So if I say that the answer is we got to multiply by the inverse of A, you have to do it on the left. Because if I put the inverse on the wrong side of it, it won't work. So trust me, since you can't just say A times B is the same as B times A. No, it's not in inverse world. It's true that we have to put the inverse of A on both sides, but this is important. See, I could totally see a kid going, I'm going to put it here, and then I'm going to put the inverse A here. No, it has to be on the left. Do you get that they're different? Inverse A times B is different than B times inverse A. So that's the right way we're going to do it. And the inverse A will just not make this knockoff, so you don't have to even show it. You're going to know that this will go away when you multiply it by inverse of A. And xy will be alone. And it'll be equal to the inverse of A times the B matrix, which the B matrix is right there. And all you got to do is figure out what inverse of A is, and the calculator could tell you what the inverse of A is, couldn't it? Right? Inverse of A. Here's the A matrix. You can just get the inverse of A. That'd be easy. That's what we're leading up to. All right. Next page. Next, I'd like you to make a 3x3 matrix for A. Let's type in this exact matrix right here. Go to edit first if you forgot that. Don't use the minus key for the 6. You got to use the negative key for the 6 and the negative 1. Double check it, because if you have one number wrong in there, like happened to a couple of you on that first time, one number's wrong in your matrix, of course everything's going to be wrong. I got your matrix in there? All right, to see if you learned anything today, I'd like you to tell me 2 things. What's the inverse of A? And what's the determinant of A? 2 completely separate questions. I know you're not doing these in your head. It's a lot of weird decimals for that inverse of A. But compare your answer to the kid next to you. You're probably doing it right if it starts with 0.101. 2 blah, blah, blah. Then do the determinant of A. It's under the math key. Brandon, what'd you get for the determinant of A?
1146.
1146. Anybody got that too? All right, awesome. when would you ever use this? Well, actually, I met a guy who was a banker, and he said that they actually use matrices out in the banking world, and they would be like interest rates in here, and then people's deposits, and they would have a mix of investments where you'd have like, I've got this amount of money getting this percent, on this amount of money getting that percent, and then they would actually multiply the matrices to figure out how much total return the person had, and he said they actually used it in banking. So, are you gonna use it in banking? Probably not. But you have a test on inverses, and that's where you're gonna need it right this minute. It's can you learn hard things? That's the theme of today. All right. So this would ask you to find the determinant, which you already got here. And this was finding its inverse, which should have been looking like that. And you just do a to the negative 1 to get the inverse. All right. I hope that was making sense. I don't think we need to do any more by hand. And coming full circle, let's wrap this up with this. How do we know if two matrices are inverses of each other? If we actually multiplied these two and it equaled 1. You could put the A matrix in your calculator and the B matrix in your calculator, and you could try A times B and it should equal 1? All right, I'm going to save you the time of doing that, but you'd enter the A matrix, you enter the B matrix, and then you go out of it and you go A times B. And it would equal 1 if they are inverses. All right, cool. There is a worksheet. Find it. Open it. Yes?
If you like multiply inverses, does it always have to equal 1? Or if they're
If they truly are inverses, it will equal 1.
will it also like, is it still valid if it equals like the 1, 1, 1 is 0?
If you got an answer of that, that is 1 in matrix world.
Okay.
That is 1. That's a good point. Okay. All right. Good. Now, let's get the worksheet open and let's do the first problem together, and I think you'll feel better when I tell you that you're going to get to skip a bunch. All right. In looking at the worksheet, we're going to do 1, and so here's the ones you can skip. Skip 3, and 6, and 8, and 13, and 15, and 16. I will repeat those. 3, 6, 8. Did I say skip 10?
No.
Okay. 13 and 16. 3, I'll write them on the board. Correct me if I'm wrong. 3, 6, 8. I know there was 13 and 16. Was there one in the middle?
15.
13, 15, and 16?
Yeah.
You sure?
Yeah.
All right. Okay, good. Now you got a bunch of problems to practice this on, and we are coming up on a test. I know it's scary. We just started this unit, it seems like, but test is Friday. So stay on top of this stuff. Take the night off and at your peril. You don't want to get behind in this stuff. So do this homework, check it against the key. Test is Friday. Question? And that's all I got for the video for today.